and got in the apprenticeship. It's a 4-year apprenticeship, and I've worked my way through the field for about 20 of those years until recently I moved up into a project manager role with A&R.
So Luke, tell us where we're at right now and kind of what we're about to see.
Okay, so this is our coil line. We've got different gauges of coil metal that it will be pulled through and can be sent out for our plasma machine to cut out fittings. We've got right now 24, 22, 20, and all the way down to 18 gauge, and that all just depends on what system the fittings have to be built to, what class they have to be built to, pressure, static, all things like that. So this machine will grab on to whatever gauge you want, bring it out, put it on a table, send it over our plasma machine for cutting.
Awesome. Let's go take a look. So this is a pretty cool setup you've got here. So this is pretty much automated. Everything that you guys can automate, you do. So tell me what's different now than when you first started.
So back in the early days, you know, we would hand lay out all our fittings and have to hand notch, shear, and form by hand. Now, with advancements in technologies, we're able to enter these in a computer, and then it brings these to the plasma machine, which, using compressed air, notches, does everything for us automated, which is more efficient and obviously more productive and more accurate.
And everything...
Big cost saver and time saver.
Exactly, and it seems that everything you do here is about quality control and efficiency.
Yeah, we definitely have a big focus on quality control and efficiency here.
Excellent. Cool. So what exactly is happening right here?
So these guys are running this through our TDF machine, which is our transverse duct flange connection. This is typically used on a high pressure system.
Okay.
There's a gasket that goes on that flange and then it's bolted together. Typically we use this on high pressure systems as opposed to our slip and drive connections, which is a slip, male and female, and then drive cleat that goes up on the sides. And the next step in the evolution from hand laying out to computer input is our VDC department, which utilizes a BIM 3D model. BIM stands for Building Information Modeling. What we can do is we can take and create a 3D model of our mechanical system, our ductwork, and it will create these spool drawings that will go straight to our coil machine or our plasma cutter and cut out and form those fittings.
Automatically?
Yep, automatically.
That's super awesome. Okay, so what's going on right here?
So right here we've got our Cincinnati automated brake, which can be set to different depths for different gauges, all in a sequence. Right now we're just bending some L angle up right now, but this machine is very useful for multiple brakes. So through our new program called M-Suite, all these systems will talk together, from BIM coordination through our VDC to our machines. That will all track, it'll track production, it'll track everything, bag and tag, multiple systems, multiple fittings.
Right on.
This will take the metal, bring it out, shear it, notch it, run it through a Pittsburgh machine here, put whatever kind of flange connection you need on it, and if needed, it will actually put insulation on there, pin spot it, and be ready. It'll break it down here on the end.
Well, this is quite...
It's an impressive machine.
Yeah, quite an assembly here. Awesome. Can we see it roll?
Absolutely.
All right, let's do it. Okay, so you were explaining that the computer is going to communicate and we're going to be able to talk to all the consoles. So tell me what's going on here.
Okay, so in our VDC department, they'll create a 3D BIM model. And what that will do is be input into M-Suite, which is our program that talks to these machines. It will download, send it to this console here. It will specify gauge, whether it gets insulation or not, what type of flange connection it gets, and basically just download all that information here to be ready for fab.
And there's 5 jobs up there right now,
Yeah,
right?
It looks like we got 5 jobs ready to go.
Awesome. Well, let's see something happen.
All right.
exciting. Okay, so tell me what's happening here.
So basically, much like our plasma coil line, this is our automated duct line. This will take a joint of duct from coil to being ready to be put together. So this machine will roll out the coils in sections. They come through, hit an infrared eye to let it know to stop. It will shear it to length and notch it for being able to be broke up. It's going to hit that infrared eye, roll through the male Pittsburgh edge. Then it's going to hit another eye to tell it to stop, roll this direction. For the female Pittsburgh, as you can see. Then we're going to roll over here to another eye. Now, depending on what die you have in, it can be set up for slip and drive or TDF. So right now we're set up for TDF. So on both transverse joint edges, it's going to form that TDF edge that we talked about earlier. It'll hit another infrared eye, tell it to stop, and it'll start pinning that insulation down, spot welding these pins in. This, obviously, as you can see, this really streamlines our process. This machine will, the whole process from start to finish for this joint alone is roughly a minute to a minute and a half. And as opposed to standard duct construction, this machine will form and break up a full joint as opposed to two sections of the same joint.
Okay, so tell us what we got here.
So basically, like we were talking about before, we saw the machine run through the Pittsburgh. This is our female Pittsburgh seam, and then you can see our male here. So basically, this just joins together.
Tongue and groove, kind of.
Tongue and groove,
okay.
Yep. You want to match up your beads here, and you'll basically tack these on each bead and an inch or two down from the drive connection here, so that when you put it in the whisper lock, that roller doesn't get caught, and it gives it a little bit more freedom to roll that down. In the past, we're cognizant of safety. Hearing loss is a big thing with sheet metal, so we still use them sometimes with the air hammers. Very loud, very cumbersome. What we can do with full joints like this is tack them down, stick them in the whisper lock, and it'll quietly roll that seam down to a smooth edge.
Ah, okay. Hence the name Whisper Lock. Got
Yes.
it. Right on. And so we got to watch this be bent right there, and now we're assembling it here. Excellent.
Yeah, you can also see the difference between a TDF flange connection and our slip and drive connection. So again, slip and drive, low pressure, TDF, high pressure. So these will, shortly, we can put these in the corner machine. It'll insert a TDF corner in here with a hole for our bolt system. Tack that over, stiffen it up, it's ready to go out the door once we get glue on it.
Right on. Okay, so what's happening here?
So this is our whisper lock. This will beat down that male edge on this Pittsburgh joint, as opposed to having to use that air hammer that we talked about earlier.
Gotcha. Right on. Okay.
So this is our TDF corner machine. For fittings, we still do have to use our hand formers.
Okay.
which clip that corner in and bend the edges over. This machine for straight joints will take care of that process for us.
Again, all about efficiency.
Yes.
Show people the variety of different things that people can do in the trades, but also, talk about how essential the trades are. And so, everything that we've been seeing here today, this is really how we keep America moving. What are these ducts used for example?
So, all of our ductwork is built to SMACNA standards, and it's for systems that move the conditioned air through a building, any and all buildings. So, there's many different types of sheet metal. You've got architectural, industrial, commercial. Commercial is what our main focus is on here at A&R. So basically what we're doing is moving that air that keeps you cool or keeps you warm when it's cold out.
Excellent. Essential.
Very essential.
Before it was cool.
Yeah.
So what's he building here?
So we went through our coil machine and how efficient that makes us on straight joints. However, we still do have fittings that need to be hand assembled. So basically what Terry's doing here is installing a manual volume damper on a short piece of duct. This is a slip and drive connection. He's welded this damper rod to this damper itself, prepped everything, got it ready for assembly. So when he gets done here, we'll put our blue on, which protects the duct from dust, debris, all those things on the job site, and it'll head out the door.
Excellent. And I read that you do government contracts, you work with hospitals, you work with lots of educational facilities, commercial buildings obviously, but I mean, I guess you would say like hospitals and schools are probably the most essential if you want to look at our society. Obviously business
Correct.
has to grow. But,
Correct. Well, there's really not a sector we don't hit, but yes, those are some of our main focus points.
and this is a very impressive operation.
Thank you.
We got to see a variety of different machines, see the efficiencies that you've been able to put into place, also VDC, and how important that virtual design is in making this flow a lot faster. So what would you say is the best part of your job here?
Of my job, the best part of my job is being able to see something come from a raw material into a product, but also just the people that we work with here. Everybody enjoys the work. It's a challenge, but it's also very rewarding.
I would imagine. And you have an opportunity to go from working on the floor to becoming
Absolutely,
management.
absolutely. I started out pretty green as far as mechanical skill when I got in the trade, but through hard work, you work your way up, acquire that knowledge and that skill, and now being in the project manager role, I can hopefully pass that work ethic and everything else on down to the guys coming up now.
And you're able to have a career you're proud of. You're making a difference. Obviously, you can support your family.
Yep.
Speaking of